Hello, everyone. Here we have Omar, who's a distinguished engineer at Cisco, and we also have Mustafa here. And Mustafa is the lead data scientist at Cisco as well, working on AI and ML engineering. And they're going to help us learn how Cisco is leveraging MongoDB Atlas Vector Search across numerous applications. So give it up for Omar and Mustafa. Thank you guys so much for being here today.
Absolutely, thank you.
Yeah.
Thank you everybody for joining us today. My name is Omar Santos. I am from an organization at Cisco called the Security and Trust Organization. And what does that mean is that we have a whole bunch of security-minded people trying to protect the company and try to protect customers. Whether it's the internal security incident response team for the enterprise or the product security incident response team for protecting products. We also have a team dedicated for offensive security where we do a lot of evaluations, not only in traditional technology, but also nowadays with AI implementations at Cisco. As you can tell, AI is going to be integrated into pretty much everything. So it's not a matter of what product will have AI, is that what product will not have AI in the future. And I can tell you that pretty much all companies, every single leader is asking their organization, do something with AI. So they're looking for AI and trying to find a problem instead of the opposite, trying to find a problem to use AI. So what we're doing at Cisco is kind of, at least in my team, is trying to balance that and drive innovation. Don't stay in the way of innovation, because if not, you also fall behind. But try to find a balance in security, because during experimentation, and I can only speak for Cisco, but I can tell you that it's pretty much everywhere the same. During experimentation, we are introducing a lot of security problems that are basic one-on-one problems nowadays, right? Including how to safely use a database. And nowadays, how to safely use a vector database that for a lot of people are new. This is not a new technology, but for a lot of people are new. And they're selecting databases, infrastructure, and so on, that they don't even provide encryption from the beginning, don't have a lot of the security capabilities that we have in other technologies. So at Cisco, we're partnering with Mongo for many, many years. It's not only big vector search, but we have a partner with Mongo, both in the product side and in the enterprise side. What I'm going to talk about here today is in the enterprise side, not creating a product or developing a product together, but how internally at Cisco we're leveraging MongoDB, and specifically MongoDB Atlas Vector Search. Right? Again, we have tons of projects. I'm not exaggerating. They're not in the dozens, they're in the hundreds. And everybody is trying to innovate. Let me give you a real life kind of example. My team, which is the whole organization, is about 800 people. What I wanted is for everybody, whether you're a PM, a developer, a data scientist, security research and so on, to embrace the technology and to try to find what are the issues in security that perhaps we're actually introducing. So we created this thing called the Innovation Challenge. And I was the first one that didn't like that term, Innovation Challenge and everything else, but it's a mini competition that lasted from November until literally last week. And a couple of kudos in here. Brian and Adam and the Mongo team has been amazing through this process. And this is only one example out of 100 that we have at Cisco, on where we created a lot of sandboxes and a lot of places where we can safely innovate and then moving things into production really quick. Right? We also went, because again, I'm the security team, and my carrot was, yeah, let's do this, but let me go through all the approval process of going into approving this environment for the most restricted data at Cisco, right? Including source code and so on. So Mongo has gone through that process so fast that I cannot tell you that there's any other company that we actually have partnered with that have gone through this process so fast, and it's a pretty rigorous process. You can ask the MongoDB team in here. We will put security as the #1 priority, and because of that, we actually have a lot of security certification and so on. But the things that I really enjoyed, one was the ease of integration, right? So currently it's integrated into a lot of different AI projects. As a matter of fact, the bulk of the presentation and the more intelligent session is Mustafa, that he's actually going to go over and give you a demo of one of many different implementations that we have at Cisco. And the second one is performance. If you actually compare this to many other solutions, there's absolutely a significant difference in performance with MongoDB versus other implementations. And believe me, we have tested a lot. And especially whenever it comes to RAG and retrieval methods. The other thing is, again, the thing that I cannot highlight enough is the MongoDB commitment to not only creating these sandboxes and moving things into production very easily for us, but they also have provided workshops internally. They have provided a lot of office hours internally. They have provided a lot of sample code. We actually co-created code in some cases. The team has been very, very amazing, and that's actually crucial for streamlining, of course, the innovation in here. So with that, what I would like to do is first thank you, for your time, and then I'm going to pass it to Mustafa. He's actually going to go over a really good example on how this actually has played well at Cisco. So thank you for joining me.
Thanks so much, Omar. Hello, everyone. I hope I'm audible because I cannot hear myself. So today I'm going to just explain you how we created one of our standalone projects, Webex QA, with the RAG implementation. So here is the agenda. I'm going to just explain the problem description, then proposed solution, and we have a demo, live demo. I hope it will work. And technical architecture, key findings, and next steps. So Webex Chat Assistant has been in production over 3 years, and then it has been used by the customers, partners, Cisco internal engineers to solve any kind of Webex related problem. Right? It's an external facing chatbot. And WCA has deflected or resolved more than 100 cases in the last 3 years, and roughly we have $10 million cost saving. And the problem is that can we leverage LLMs, right, to expand this ability across all the Webex articles, help articles we have. Right now we have 3,600 Webex help articles, and with the current FAQ model, we just cover a small portion of it. And then can we also reduce or eliminate to need to manually create QAs? So basically, like in the AI, if you want to create an FAQ type of model, you need to first define what kind of areas you need to focus on, right? And then main question, and then the answer, like the curated answer. And then you need to create variations of this question, and then train a machine learning model. Right now, the current model in production is basically based on this architecture. With the LLM, we are like trying to switch a RAG type of implementation. Okay, the proposed solution is the apply RAG LLM as a framework, and then use publicly available help.webex.com articles. As I said, we have 3,600 documents, and personalize the answers based on the persona, product or service, application, and device. So why it's important? Because we want to provide seamless experience to customer, and then we also know KYC. And we have 3 options. KYC, which comes from customer, right? Based on the previous transaction with Cisco. The other thing, UI, we provide all these options in the UI as well, which I'm going to demo it right now. And the third thing is that extract all these entities from the question. So we do combine all these entities, metadata, and then provide the answer. Okay, so this is the most challenging piece, I will say. So on the left-hand side, these are all the requirements which come from business. The business says that, hey, index the most up-to-date content of the help articles periodically, meaning that the documents we have are living documents. These are not static. In a daily basis, they got changed. And incorporate the hyperlinks and citations of the documents in the answer. So normally, if you are like the familiar with RAG type of model, once you load the data, you need to chunk into the pieces, right? And then there are a few, like say, methods to do that, like character-based chunking or paragraph-based chunking, parent-child approach, so on and so forth. So in our data, we have lots of hyperlinks where we needed to go a custom chunking strategy to keep all these hyperlinks intact during the text processing steps. And then provide the hyperlink source documents, the prompt, and the computation time as needed. We came up 2 different UIs. One is for the user, the other one is for the engineers to debug what was the query, what was the current FAQ model generated, and what was the output from the GenAI model, source documents, prompts, and the computation time, so on and so forth. And keep the answers of the positive feedbacks in cache to decrease down the response time, as well as the cost, right? So as I said, our documents are living documents, and our cache database is a kind of should take into account all these approaches, all these problems. And then we came up with auto update cache vector database, and as you know, mask PII data, and then create a guardrails for prompt injection, toxicity, and profanity. Now I'm just gonna demo what's the current let's say product we have. So as you see, we have 2 different UIs. The first UI is demo mode false. It's basically for the developers who will see what's the output from the RAG model. And then we have another one, which is demo mode true. It's basically for the end user who will only see the answer from the GenAI. So I can choose the user, administrator, or partner. These are our personas or roles, right? The customer might come up with. And then we have product and application or device. For the sake of the simplicity, I will just go with the user because user is default. So if I ask a question, I need to create a poll questionnaire on a Windows system. So the answer which pops up is from the current FAQ model we have. Okay, so as you see, it's identical with the first answer, and then we have the curated answer right now, which is curated by the engineers. Okay, so I'm just going to go up. And then since these documents are all living documents in which each release, the engineers should check which documents are updated, and then they should reflect the modification or update in their current curated answer, right? So the answer comes from the RAG model. As I said, like we have the custom chunking strategy, custom splitting strategy, so on and so forth. That's the reason why is that we need to keep all these hyperlinks in the answer. As you see here, we have an hyperlink, and then if the customer clicks that hyperlink, it will go to that document in Webex domain, and then in that specific space, right? So source documents as well are here. We have 2 documents where we extracted the data, and then the prompt, and then the response time. Response time, we have 3 different response times. The first one comes from the vector database. The second response time, like the computation time, is between just after the vector database to GenAI, like the consolidation process we call it. And the third one is the output from the GenAI. As you see, it took 16 seconds to get the output from the GenAI, which means that there is a high latency here, which we need to decrease down this latency with the cache vector database approach. So right now we have this output, and if the user gives a positive feedback, we have 2 options, positive or negative feedback. What happens is that in the back end, we just get this query. Whenever we get positive feedback, we create 3 different variations. Okay, we use GenAI to create 3 different variations, and we index these main question and then the 3 different variations into the cache vector database to increase the likelihood to get the proper answer once the customer comes with different query or the like the similar query. And in the Webex domain, we have a Webex space where we get all these notifications to the SMEs, and then SME also sees that, hey, we got a positive feedback, and this is the response, so on and so forth, right? So this is how the cache vector database is indexed. And next time, I'm just like taking one of the queries from here and ask another question which is different than the one we have, and then it directly will go to the cache vector database and generate the output. Okay, right now, whatever the first communication from the customer to vector database is cache vector database. If we have, like the similar answer based on the similarity score, the output comes from the cache vector database. Let's say I give another positive feedback for this one. It also still triggers the positive feedback space. And then at the same time, in the back end, we created another query, same query. It is also linked to the master query, wherever we get the first positive feedback, because the output also comes from the cache vector database. In the cache vector database, what we have is right now 5 outputs, not 2, 5 outputs. If you look at here, this is the main query. And we have 3 variations here, which comes from the Gen AI. And this is the final one I gave positive feedback. And the first one we get positive feedback is the primary, and the rest becomes as an secondary under the same hash code. Why it is important? Because next time, once we get negative feedback, we also clean the questions from the cache vector database, as well as I said, this is living documents, right? So in the cache vector database, you will see that these documents have external IDs. Okay. So in the Webex LLM notification space, in a daily basis, we run a cron job to get which documents are updated. And these documents also shown to the engineers or the business. Hey, yesterday we had 3 documents are updated. We don't know like which places in these documents are updated, but we like certainly know that these documents are updated. The update, the modification is reflected into the vector database instantly. Okay, vector database is up to date all the time, but how we are gonna modify or update the cache vector database is based on the external IDs. So let's say we have 4 questions which are in the cache vector database, and 1 document is updated. Then what we do is that pipeline is triggered, extract these questions from cache vector database, and then based on the question and then the persona metadata, we hit Gen AI again to generate the answer. Then we have an evaluator. Evaluator evaluates these question, answer, and the context, and then comes up with like the similarity score, right? Relevancy score. If it is above a threshold, we say that, hey, the answer is still valid, and we index it into cache vector database. If it is less than a threshold, I'm talking about the context relevancy, answer relevancy, and then the faithfulness, right? These three metrics are important for us. If it is above threshold, directly we update the cache vector database. If it is not less than, if it is less than threshold, it is sent to SME, and then SME just checks the answer based on the new updated, let's say, content, and says that, hey, this is good, this is true, and then we update the cache vector database. Okay, so how about the negative feedback scenario? If customer comes up with the same question, right, and then we have the answer from cache vector database, right? It's instant, and then in less than a second, like we get the output, and then we got negative feedback. I still need help. This is not the answer I'm looking for. We request the customer to justify it. Hey, it did not work for me. Okay, so if this feedback is sent in the back end, the engineer gets the negative feedback notification. Okay, the SME gets the negative feedback notification, and then checks through what's the issue here. So 2 options. either it will discard, he will discard or accept it. If it is discard, then there is nothing happens, right? So we are all good. The negative feedback is rejected, and then the interim collection is clean. Okay. So if it is selected as accept, same query goes to the cache vector database. Cache vector database generates the answer. This time we still get a negative feedback, and then engineer also sees that, hey, I accept, yes, this is not the answer of this question. Then we clean the relevant, let's say, questions and answers from cache vector database, and but it's based on the semantic relevancy score. We are not gonna clean everything, right? Because the question might be different, and then the answer might not be correct. That's the reason why we put a kind of threshold. If it is above threshold, we clean all these different, let's say, documents. Right now, if I come back here and then run the cache vector database, there is nothing here, so it's 0. Everything is cleaned in cache vector database, because these questions we asked, once negative and positive feedback, these were almost identical. So this is basically the demo, and I'm going to go back to the slide how we created all that thing, and then technical architecture. So we have 3 phases. The first one is the indexing phase. The second one is inference phase, and the third one is caching phase. Okay. In the indexing phase, as I said, these documents are all live documents, and we have 2 APIs. The first one is that metadata API. The other one is content API. At the very beginning, we do run through all these documents. Okay, and then metadata API gets all the metadata of these documents, everything end to end. What's the content URL? What's the persona? What's the product? What's the operating system? Keywords, so on and so forth. For every each URL, we make the content URL API call to get the content. And data controller does all these API calls. Then, as I mentioned, right, we need to keep all these hyperlinks and the citations intact. That's the reason why we customize the convert to text and then splitting and chunking. But the data loader, we use only llama index simple web reader, which also just like the processes all these hyperlinks properly. Okay, other than that, these are all like the customized by ourselves end to end. This is like the Python code. So once we get this data, splitting and chunking is, as I said, this is customized. We split the text into the sentences, and then we created our own code. I think we have more than 50 rules. Based on these rules, the chunk is split into the sentences, the text, and then 12 sentences becomes one chunk. And then we have one sentence overlapping strategy, which I'm going to explain it right now. So then we have the embeddings API and Mongo Atlas vector database, where we do index all that stuff. Okay, so this is the data where we get from the content URL, the API. This is all HTML data. Whenever we apply our own chunking strategy, right? So the output is the list of sentences, and 12 sentences become one chunk, and then one sentence is the overlap. And this is one of the documents I show you, and then we have 3,600 articles written in English. And this is the output from the like the data chunking and splitting pipeline. Okay, so title we have, and then the URL. The URL we get the content, and then the document. As I said, we have 12 sentences. The first sentence is the title of the document, which is common across all these paragraphs. Okay, then we have the description as a second sentence for the first chunk, and as you see, we just keep all these citations and the hyperlinks intact, right? And then we have the index and total index numbers. These also come from the document itself. what it does is that the index itself shows the paragraph's position in that document. So this is the first paragraph. And the total index is how many paragraphs we have in this document. Why it is important? Because once we get the output from vector database, we do make a kind of anchor and anchor strategy, like the check one previous and one after, like the paragraphs, and concatenate them, create one big chunk of text. It is different than the parent-child approach right now the industry uses. This is solely like the created by ourselves, right? So our approach is like not only go with a specific paragraph, but take into account one previous and one after paragraphs as well, and then combine them. Right now, 2 paragraphs we have from one document. As you see, like the document title is always first sentence in that paragraph, and then the last sentence from previous paragraph becomes the second sentence of the next paragraph. This is how we chunk and then process the data. And here we have the inference phase. I'm not going to touch upon the caching phase, but in the inference phase, we have the virtual chat assistant. It's in Rasa framework, which ingests the input from the customer. Okay, and then Rasa NLU also identifies that, hey, this is an FAQ model. And then once it is identified as an FAQ model, we get the output from the embedding API and then hit to cache vector database. If the output from cache vector database is less than a threshold, then it will directly go to the GenAI. If it is above the threshold, then we will like pass the answer to the VCA, virtual chat assistant, and then it will send back to the customer. So if it is less than threshold, as I said, get the output from Mongo Atlas Vector Database, and then output consolidation process, as I explained, right? One previous, one after approach. And then we have dynamic prompt, and then we feed the GenAI to get the final output from the GenAI. It's roughly the solution. Oops. Okay, so key findings. I mean, if you want to put RAG into production, and then if the latency is a kind of concern for you, then there are lots of bottlenecks and hiccups in front of you. The first thing is that the latency itself. The latency right now, it takes 5 to 15 seconds to get the output from the LLM, and then that's the reason why caching is pretty important for us. Like coming up with a caching mechanism is pretty important. And then, as I said, like these Webex documents are all living documents. Like in a daily basis, 5 documents or a few documents are updated. We need to keep the cache vector database as well as the main vector database up to date with the new content. And then I show you the debug mode. The debug mode also expedites the performance analysis at all levels. So anyone in the business side, right? Go to the debug mode and then check what was the output from the FAQ model, from the RAG model, what was the prompt, what kind of documents we took into account as a source documents, and what was the output, like the computation time. So that debug mode is extremely useful for SMEs to see the prompt, source documents, time taken at each step, right? And then the good thing is that we have 450 questions and answers curated, which will be able to help us to evaluate the current model performance. This is also another, let's say, advantage for us. Yes, I think we are done.
Let's give it up for Omar and Mustafa one more time. Thank you both so much for coming all this way.